engineering teams review pull requests through disconnected tools. Code review shows what changed. Continuous integration shows what passed or failed. But neither provides one clear answer to a more important question. What is likely to happen because of this change? And what should the team do next? This is IMerge, a developer tool that analyzes the likely consequences of a pull request before it is merged. A developer can paste any public GitHub pull request URL without creating an account. They can also submit a small Git bundle or upload a project archive together with a diff. For this demonstration, I'm submitting a public pull request that was not built into the application. The system retrieves the changed files, examines the repository structure, discovers relevant tests, and builds dependency evidence. Submitted repository code is inspected as text and metadata. It is never installed or executed. The result is divided into 3 layers. Observed contains facts retrieved or derived directly from the repository, including changed files, imports, tests, checks, and package relationships. Predicted contains the likely blast radius, structurally recommended tests, a transparent heuristic risk estimate, and workflow predictions when sufficient history is available. Suggested compares possible next actions. For example, the team can run a selected test subset, run the complete suite, request another reviewer, split the pull request, or rerun a field check. Every prediction includes evidence, confidence, assumptions, and limitations. Missing information is marked as unavailable instead of being converted into a confidence score. Here, the system identifies the modules likely to be affected, explains why each test was selected, and shows the factors contributing to the risk estimate. The scenario comparison then recommends the action with the best balance of technical risk, feedback time, and CI cost. GPT 5.6 generates the final explanation from a bounded evidence pack. It explains the existing analysis and refers back to repository evidence. It does not invent or replace the numerical predictions. The application uses a next.jl and TypeScript frontend, a Python fast API backend, GitHub APIs, repository graph analysis, structural test discovery, transparent prediction baselines, and the OpenAI responses API. Chat GPT 5.6 Sol was used extensively for research, product ideation, architecture, critical review, and orchestration. Those implementation goals were then transferred into the main Codex session. Codex with GPT 5.6 produced most of the application code, integrations, automated tests, debugging work, and deployment configuration. I remained in the loop by testing each iteration, identifying weaknesses, redirecting development, and making the final product and submission decisions. IMerge helps engineering teams see what a change may affect, what should be tested, what could go wrong, and what they should do next, before they merge.